Hi everyone, Senan on this side, and in this video we are going to see this binary tree Inorder traversal. So most probably you would know the solution to this, but I would show you two solutions. One you would most probably you would know. The second one I doubt that you would know this solution. So stay tuned till the end. Okay, so the first one is the most obvious one, is the recursive solution, right? So what is the Inorder traversal? Given a node, first you process all the left subtree, and then you process the node, and then you process the right subtree. Basically that is the way. So to do this, given I make use of a helper function which takes an array of input or array of integers, basically a vector int, and you basically return that answer. So what does this helper do? So if the node provided to this helper is null, you don't do anything, right? Because there is nothing to process. Otherwise, what you do is you first process the left tree. After processing the left subtree, you take this current node value into your answer, and after doing that, you process the right subtree. And this is the most straightforward and the most obvious approach. And if I just change the location of this pushing, you would get in this case you would be getting a pre-ordered traversal. Otherwise, if I push this to the end, you would get the post-order traversal. So this is quite obvious, but if anyone asks you this question, the only reason would be to ask this follow-up question. You have the recursive solution, which is literally trivial. You have at most 7 to 8 lines of code, right? Can you do it iteratively, right, without a recursion? So that is the main idea of this video, and the answer to that is yes. Basically the idea would be, starting from the root, you go as left as possible and keep track of all the elements you visited, and once you reach a node which has no left child or no left tree, you take that value into your answer. After doing that, you go to check the right side of that node. So that is the logic we are going to use. Basically we have an answer array or vector int of answer. We need to have a stack. Obviously we are basically doing a breadth first search traversal, so in that case what you have to do is basically have a stack. If you use a queue, that would be some sort of queue traversal, breadth first traversal. So first of all, what you do is initialize this new pointer current to this root, and what this does is, let's say if stack is empty and the root is null, in both the cases this would evaluate to false, and then you would go out of this while loop. So basically you return an empty vector. Otherwise, if root has some non-null values, you would go into this while loop, and what you would do is go as left as possible using this while loop. While current is not null, you push this current into the stack. Basically you keep track of all the elements that you visited while going down towards the left, and after that, when you come out of this loop, then the current would be null, right? Because when you go down and down, at some point the tree would end. So the node from which we got the current as null is stored in basically the stack, and to get that value of the parent, we can just do st.top and we get this current value, and we just pop this from the stack because we are about to process this node, and what we do is we append that value to the answer. Okay, that's good. Now what I do is I change this current to current dot right. Basically that means now I have processed the left half of the tree. I have processed the node. Now I have to check the right part of this node or right subtree. Now again, after this, we again go into this while loop, and again we do the same thing. We go as left as possible. We take that node into consideration. We pop that from the stack. We add that to our answer, and then we check the right subtree because we have processed the left subtree, we have processed the node, and now we have to process the right subtree. And now if you see, this answer would work as well as this. Both of this solution would give you basically this 100% acceptance, or more or less near about that. Let's do a dry run of this one in this what do we say this test case basically. Now initially the root is 1, fine. Now you go as left as possible. Now you get into this while loop. Stack is empty but current is not null. You get into this while loop. Your current is not null because current is pointing to this root, and you go as down as possible while pushing the elements into the stack. So current, I push this element into the stack, and basically my stack element is having 1. Now I do current is equal to current dot left, so I reach a null, so I reinitialize this current to this 1, and I just pop this element. Fine. Now I push that into our answer vector. So answer is containing now 1. Now I say current is equal to current dot right. So now current is 2. Again I go to this while loop. Stack is again empty, but current is not null. Now since current is at 2, I push this 2 into the stack and go towards the left. Now we reach 3. So the stack is now containing 2. Now again I would go to the left and push 3 into the stack. So my stack is now having 3 as well. And I again try to go to left and I reach null. So what I do is I take this current and assign this to st.top. So now my current is basically pointing to 3, and I do st.pop. So my stack is gone, and now I push that to my answer array. Fine. Now I take this 3 and I assign current to current dot right, which is null again. For this 3 there is no right child, so current is null. Now again I go into this while loop, but this time current is null but stack is not empty, so we won't go into this while loop at all, and we just take this current is equal to current dot top. So current would now be 2. Then we pop this, so I'll pop this from the stack, and after that I'll push that into our answer. And now I would say current is equal to current dot right. So now current would be pointing to the null pointer, which is non-existent child of 2. And again you come into this while loop, you see stack is empty, you see current is also empty, so you don't go into this while loop at all, and what you return is the answer, which is 1 3 2, as you see, which is the output. So hopefully you understood this. This is the most important thing that you should know in this. What is the time and space complexity? Time complexity is basically the number of nodes. At least you need to see each and every element once, and the space complexity again would be big O of number of nodes, because let's say if you have a skewed tree like a linked list, you would store all the elements into the stack. And yep, that is the video all about. Don't get confused with this 2 while loops. That doesn't mean that you multiply the time complexity in this case, because in the end you would basically travel to each node once and do some processing, which would take a constant time. So yep, that was the video. Hope you enjoyed this, and yeah, bye. Thanks for watching.